Now I've taken the time and gone ahead and plugged those into my calculator, and these are my numbers. So now I'm going to go ahead and graph them. Now notice I have a blank graph here. I'm going to have to put an X and a Y axis on it. I wanted to go ahead and look at what kind of numbers I have. My x-axis I have from -2 to 2, but on my y-axis it looks like I have not quite 0 up to 25. So I'm going quite high. So I'm going to go ahead and put my y-axis, nice straight line, but I'm going to move my x-axis down toward the bottom since I don't seem to have much for these y's as far as negatives go. So at -2, actually let's go ahead and switch colors for the graph. So for -2 I have 0.004, it's really small. -1, I have a point that's just a tiny bit bigger than that, still not much though. At 0 I have 1. At 1 I have 5. 1, 2, 3, 4, 5. At 2 I have 25, and I don't even think that'll fit on my paper. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it's way off my graph. So what I'm seeing here is that it's growing very quickly, and of course I would try and make this be a little bit straighter. Now if I continue to plug in negative numbers, what I'm going to notice is it's going to get smaller and smaller and smaller, but it's never ever going to get to be 0. And you can probably figure that out if we think about this for a moment. In order to get 0, what would my x have to be? Can you take 5 to any power and get 0 out of it? Well, the only way to ever get 0 out of anything is you could add something that is its opposite, which we're not doing any adding. Excuse me. You can multiply by 0, but we're multiplying by 5. And so never ever will I be multiplying by 0, so that's not going to happen. So it's not possible to get 0 out of this. Since that's not possible, I'll never ever hit that. If I'm approaching a line but I never ever hit it, that's called an asymptote. So let's go ahead and look at the next one. We're going to do the same type of thing. We're going to create an X and a Y table. We're going to pick some X's to plug in. I tend to just try and be symmetric. You could do other ones if you wanted to. Excuse me. We're going to plug that in. So now notice it's a negative x, so it's a negative -2. If I subtract a -2, it actually becomes a positive. 4 to the -1 again becomes a positive. 4 to the -0, 4 to the -1, 4 to the -2. I went ahead and filled in those numbers after plugging them in. Again, I see myself getting quite high. I'm going up to 16, again getting low or close to 0. I stayed symmetric, so I'm going to do very similar to what I did on the last one. Put my y-axis down here. I'm going to put my x-axis toward the bottom. So I have a point at -2 and 16. 1, 2, 3, 4, that's 5, 6, 7, 8, 9, 10, 13, 14, 15. It looks like I have just 16. -2, 16. At -1, I'm at 4. At 0, I'm at 1. At 1, I'm at 0.25, 2.0625. Again, I can see how I'm growing quickly, but actually as I move to the right, this graph is actually decreasing this time. It's actually getting smaller. And so if you look at the two graphs, if your x is positive, you're increasing as you move to the right. If your x is negative, you're decreasing as you move to the right. Now the process doesn't change even if you get a little crazy with your exponent. In this case I am x equals or sorry, 4 to the x plus 2/3. So the x plus 2/3 is my exponent. I'm going to treat it exactly the same. So when I do this, it's just 4 to the negative 2 plus 2/3. 4 to the negative 1 plus 2/3. 4 to the 0 plus 2/3. 4 to the 1 plus 2/3. 4 to the 2 plus 2/3. Again, I've gone ahead and filled in what they equal to. I see I'm really close to 0. Got some big numbers. This is 40.3. Not going to probably graph 40.3. That's pretty large, but I can graph some of these other ones. There's my y-axis, my x-axis. Negative 2 is almost 0, but not quite. Negative 1 is a little bit over 1/2. 0 is at 2.52. 1 is at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 2 is at 40, which I'm definitely not going that high. But again, all of these you can see have that nice curve, shows that it's growing quickly or it's decreasing quickly. There is one formula that is very similar to all these equations, the fact that we have an exponent. And well, actually there's multiple formulas, but this is one example. So it's called the compound interest formula. If you have a savings account, if you have any kinds of loans, all of your accounts use compounded interest when they're finding the interest, right? Interest that you are either paying or interest that you are hopefully getting. So let's first define what all these letters mean. So S is the final amount, or in the financial word, that's your maturity value. Capital P is your principal. It's the amount that you're putting in. It's your beginning amount. You can also think about it as how much did you borrow, right, for your vehicle or for your house. Your R is your rate. You want to make sure you put it in as a decimal. K is how often you are compounding. And then T is time, and your time is in years. So if you happen to have a problem that is a partial year, like maybe 6 months, make sure you put in 0.5 for your years. So we're just going to do one example of this. We're going to deposit $1,000 in a savings account at 6% for 5 years. How much money would we have if our account compounded? And we're going to practice 3 different ways. So, 4 different ways. In each one of these, our K is going to be different because that's the part that's changing. In annual, our K is just 1. In semi-annual, that's twice a year. Quarterly is 4 times a year, and monthly is 12 times a year. So this K is going to change depending on if I'm in A, B, C, or D. The rest of it's going to stay the same overall. So S equals, I'm finding my final amount. I'm plugging $1,000 into the account. My rate is 6% as a decimal. Remember, that's 0.6. We'll go ahead and start with our annual compounding. So our K is going to be 1. Over here it's 1 times how long we're leaving it in, which is 5 years. So we're going to work on this in my calculator. Depending on your calculator, some can plug this all in, some can't. I'll give you the answer, that way you know what you have to be able to figure out how to get it there. If you struggle with getting your calculator to work, let me know what calculator you're using and I can help you out. So with this calculator for A, I ended up saying that, or getting, that I will have in the account at the end of 5 years $1,388.23. So I made $338. Now I'm just going to switch for B, and my K is going to become 2. So I'm going to cheat a little bit. I'm going to take that out and that out. And I'm going to switch to 2 and then 2 times 5. So I end up with that my account at the end of 5 years now has $1,343.92. You can see I made an extra not quite $5 by having it compound twice a year instead of just once a year. On the next one, my K has turned to quarterly, or 4, so I'm going to replace this 2 with a 4 and this 2 with a 4. Everything else, notice, is staying the same. This time I end up with, at the end of 5 years, I have $1,346.86. It's going up a little bit more each time. And last but not least is if I compound monthly, so I'm going to change the 4 to a 12, because monthly is 12 times a year. And so I end up in this, if I was compounding monthly, my account would have $1,348.85. So it's not a huge difference, but it is only $1,000. So you can imagine if you had quite a bit more in there, it would start to make a big difference how often you are compounding. So in this section, make sure you can plug into your calculator, make sure you can graph an equation, and that you can use this compound interest formula. Have a good day.